In a weighted voting system, there are various ways that we can calculate just how much power an individual player has. Now, we've seen examples where individuals have varying amounts of power, so we need some kind of system to determine just how powerful an individual player is. So one possible way of doing this is called Banzhaf power. So to talk about Banzhaf power, we need to first define a few words so that we have a working vocabulary beyond just our weighted voting system vocabulary. So we need the idea of a coalition. Now, a coalition is any set of players who decide to join forces and vote the same way. Fair enough. Simple enough. Right? The grand coalition is the one that consists of all of the players. Assuming it's a well-designed weighted voting system, the grand coalition will always be what's called a winning coalition. A winning coalition is any coalition that has enough votes to win. On the other hand, a losing coalition is one that does not have enough votes to win without bringing in new players. Now, a player is considered a critical player to a coalition, to a winning coalition, if they're needed, their votes are needed in order for that coalition to remain a winning coalition. And we talk about, with respect to critical players, this idea of a critical count. The critical count is the number of times the player is a critical player. So if we make a list of all of the winning coalitions and we determine the critical players within these winning coalitions, the critical count for each player is going to be how many times they were a critical player within these winning coalitions. So now that we have that vocabulary underhand, we can start talking about Banzhaf power. So the Banzhaf power index is a ratio of a player's critical power, their critical count, to the total critical count. So we're looking at how many times are players critical players total, so adding up everybody's critical count. That's our denominator. And our numerator is the individual player's critical count, how many times they are a critical player for winning coalitions. And we end up with this ratio. Now, a lot of times when we end up with ratios, it's really common for us to want to reduce them. When we're talking about Banzhaf power indexes, we don't reduce these fractions. We leave them as having a common denominator across the board. Now, it might be harder with the common denominator for you to know that, say, 7/28 is about 1/4. You might have to be thinking in your head that, but what it does is it keeps it so it's very easy to compare one player to another by having the common denominator there. So all we have to look at is numerators to compare them. Now, Banzhaf power indexes give us this ratio for each player. Now, when we put them all together, what we get is called the Banzhaf power distribution. This is the complete division of that power pie that's created by taking the total critical count, by adding up the critical counts for all of the players. Now, sometimes if the total critical count, so when we added them all up, is a large enough number, we'll talk about the Banzhaf power distribution in terms of percentages. Now, we do that because it makes it a little bit easier to look at and to really know like what percent of this power pie does each player have. But what we lose in that is that it might not add up to 100% when we're done, because we're going to have to do some rounding, almost guaranteed. And that's not an ideal situation to be in. So whenever possible, we want to leave these things as fractions that are unreduced. Now let's take a look at an example of going through from having a weighted voting system with each of the players' weights and the quota, and computing the Banzhaf power distribution. So we're going to compute the Banzhaf power distribution of the example of a weighted voting system with a quota of 4 and 3 players with weights 3, 2, and 1. And what I've set up here is a table for our example to go to the right and the steps that we need to follow to compute the Banzhaf power distribution on the left. So we're going to follow these steps as we go. So first we're going to make a list of all possible winning coalitions. Now, it's helpful to sometimes make this list in a table form. We're going to list them out here side by side because we don't have too many in this example. So possible winning coalitions have to have at least 4 votes. So we can see that when we put player 1 and player 2 together, we have 5 votes, and that's a winning coalition. We also can see that when we put together player 1 and player 3, that's enough to get our 4 that we need. And when we put together player 1, player 2, and player 3 all together, that's also enough votes with 6 votes. Now, if I try and take player 2 and player 3, my other combination there, I only get 3 votes, which doesn't meet the quota of 4, so it is not a winning coalition. Similarly, any player by themselves does not have enough votes to win. So these are my 3 winning coalitions. So then within each winning coalition, I need to determine critical players. To do that, you should take your winning coalitions list and you should underline which players are critical within them. So looking at my first coalition, player 1 and player 2. If player 1 leaves this coalition, then I only have 2 votes remaining, making player 1 a critical player. Likewise, if player 2 leaves this coalition, I only have 3 votes and not the 4 required to win, so player 2 is also critical. Similarly, in my second coalition, if player 1 leaves, I only have 1 vote remaining, making player 1 critical. And if player 3 leaves, I only have 3 votes, leaving me short of the quota of 4, so player 3 is also critical. Now, in my last coalition, if player 1 leaves, then I'll only have player 2 and player 3's votes remaining, or a total of 3, which doesn't make my quota of 4, so player 1 is critical. Player 2, if they leave, I'll still have player 1 and player 3 with 4 votes, making my quota. And if player 3 leaves, I'll still have player 1 and player 2 with their 5 votes, making the quota of 4. So player 1 is the only critical player in my third coalition. So then I need to find the critical counts. Now we use the variable b for the critical counts, b for Banzhaf. All right. So b is for my critical counts, and they have subscripts corresponding to the players, similarly to how the weights had the subscripts corresponding to the players previously. So b sub 1 is the number of times that player 1 is a critical player. So player 1 is a critical player in each of the coalitions. So player 1 is a critical player 3 times, making b sub 1 3. Now looking at player 2 is a critical player in the first coalition, but not in the second or third. So player 2 is a critical player once, making their critical count 1. And similarly for player 3, they are a critical player in coalition 2, but not in 1 or 3, so they are a critical player exactly once. Now, we need to find the total critical count. We find the total critical count, or T, by adding up b sub 1 plus b sub 2 plus b sub 3. Adding up the critical counts for every player. So this is going to be 3 plus 1, or 5. So my total critical count, or T, is going to be 5. Now finally, I compute the Banzhaf power indexes. Now for the Banzhaf power indexes, we use the Greek letter beta with the subscript corresponding to the player. So beta sub 1 is going to equal b sub 1 divided by t. And in this case, b sub 1 was 3, t was 5, and remember we don't reduce these fractions, so beta sub 1 will be 3/5. And we'll do the same thing to find beta 2. It's going to be b2 divided by t, which is 1/5. And similarly, beta 3 is going to be b3 over t, giving us 1/5 as well. And the Banzhaf power distribution is simply stating all three of these Banzhaf power indexes together, saying that beta 1 is 3/5, beta 2 is 1/5, and beta 3 is 1/5.